Hey all, today we are going to continue talking about right triangles, and we're going to talk about trigonometry. Trigonometry might sound like something that's scary, but really it's just a set of relationships that exist in right triangles, just like we talked about with the special right triangles, just like we talk about with Pythagorean theorem. There's relationships that exist between sides and angles in these unique triangles, these right triangles. And trigonometry or trigonometric ratios, that's sometimes difficult to say, are just relationships that exist between the angles that are not the 90-degree angles and the sides in the right triangle. So let's look at um, one of them first. So actually I'll say this, there are three ratios. We have this thing called the sine ratio that we abbreviate to be, a lot of people say sin. We have the cosine ratio. We abbreviate to be cos. And we have the tangent ratio. We abbreviate to be tan. And these are just relationships that exist between a specific angle, that's the non-90 degree angle, and um, two of the sides in the triangle. So let's look at angle Z here. So I want to write these three ratios for angle Z. And so first thing we need to do is establish the way that the sides are related to the angle. And so we have the hypotenuse, of course, that's across from the 90. And we have a side that's opposite. I'll abbreviate that. It's opposite from the angle we're looking at, angle Z. And then we have this side that's next to angle Z. The word we use for that is adjacent. I'll abbreviate that to ADJ. Adjacent means next to. So this side is next to the angle. The hypotenuse is also next to the angle, but it's across from the 90. That's a specific side. And then the other side, the opposite side, is opposite from that angle we're talking about. And if we were to be referring to angle X, what would happen is the opposite and the adjacent sides would switch. The hypotenuse is always the hypotenuse. And so these relationships that exist are that the sine of an angle, and we use this symbol, this Greek letter theta, it's a circle with a line through it. We use that to represent an angle measure, is the relationship between the side that's opposite from the angle divided by the hypotenuse. And I'm really starting to abbreviate a lot here. The cosine of any angle is equal to the adjacent side divided by the hypotenuse. And the tangent of any angle, we'll use theta, again that Greek letter, is equal to the opposite side divided by the adjacent side. There are many ways to remember these. These can be found on formula sheets often. We can talk about ways to remember these in class. And so if I wanted to just write the sine, cosine, and tangent of these three, I'm writing the sine of Z, so that's my angle name, so I'm going to say sine of Z, and we can put them in parentheses. My opposite side is 40. My hypotenuse is 50. And so we would simplify that to be 4 over 5. So the sine ratio, my fraction that I get, is a ratio for this angle Z in this right triangle is 4 over 5. The cosine of angle Z is the adjacent side, 30, over the hypotenuse, 50. And we can simplify that to be 3 over 5. And you can use Desmos to help you simplify if you need to. I'll stay red. And the tangent of my angle Z is going to be the opposite side, 40, divided by the adjacent side, 30, which simplifies to be 4 over 3. And I'm always going to encourage you to label the sides of your right triangle, opposite, adjacent, hypotenuse. You can just use O, A, and H. I'll always encourage you to write the relationships every time. The more you write them, the better you'll remember them. And so let's talk about angle X here. I'm going to set up my hypotenuse is right here. I'll say H. It's opposite from the right angle. 36, that's the side that's next to my angle. We'll call that A for adjacent. And then 15 is O for opposite. And so we can find the sine of x, the cosine of x, and the tangent of x by using the way we labeled and then the relationships we have up here. So sine is always opposite over hypotenuse, so the side opposite is 15 divided by the hypotenuse, which is 39. And I think we can simplify that to be 5 over 13. Cosine is the adjacent over the hypotenuse, so 36 over 39, which is going to be 12 over 13. And tangent is always opposite over adjacent, so 15 over 36. So we're going to get 5 over 12. I hope that you can see, like, this is just plugging in numbers. If you write down the relationships and you label the sides OA and H, all I have to do is plug the appropriate numbers in for the trig ratio that I'm interested in finding. So I want you to try one of these. I'll give you one that's pretty straightforward to simplify. So try number 3. Let's find sine, cosine, and tangent of angle Z. So pause right now, write the ratios for sine, cosine, and tangent for angle Z by first setting up which one's O, A, and H, and then using the ratios that or hopefully you wrote down from earlier. So go ahead and pause, try this one on your own, and then press play for the answer. So hopefully you labeled this right. If you didn't, now's the time to raise your hand and ask a question. And then plug in O, A, and H where they belong. So sine is O over H, cosine A over H, tangent O over A, and then simplify. Again, you can use Desmos to simplify. If you need help with that, again, raise your hand and ask me for some help, and I can assist you. So as we've talked about a lot in this class, this is a lot about relationships and then using relationships to find something missing. So of course we're going to jump into finding some missing things. In this case, we're going to be finding the length of a side that's missing. In a right triangle, if you know how long two of the sides are, you can always find the third side by using Pythagorean theorem. If you have a special right triangle, like a 30, 60, 90, or a 45, 45, 90, you can use the special right triangles. But if you don't have either of those cases, your last way to do that is to use trigonometry. And all we need to know to find a missing side length using trigonometry is to know one side length and know one angle measure. So I know this angle of 29. And so I'm going to label my sides O, A, and H. So 13 is H, my hypotenuse. This side that's X is next to my angle. That's my adjacent side. And so this side is my opposite side. And then I'm going to go ahead and look, what do I have labeled? Well, I know my hypotenuse is 13. And I'm looking to figure out how long my adjacent side is. So if I go all the way back up here, or if I write them down again, the ratio that has A and H in it is cosine. And so I'm going to write cosine of my angle. This time I don't have a letter, I have a number, 29. Is A over H, so A is X, H is 13. And now what I have is an equation to solve for X. And cosine of 29, that's a function that we could put in our calculator. Let me show you how to do that. So if you go to Desmos, we have this button that says functions, trig. We have trig ratios. Those are the fractions we were writing. The actual sine, cos, tan, those are functions. We can plug things in to those things, and they will give us some numbers. So I have the cosine, so I'm going to do cos, and my angle was 29. And you can see we get a decimal. I'm going to take maybe the first four numbers here, 0.8746. So the cosine of an angle of 29 is 0.8746. What that's saying is if we divided the adjacent side by the hypotenuse, that fraction in our calculator would be equal to this decimal. So 0.8746. So our fraction x over 13, our ratio, our cosine ratio, should be equal to this decimal. And so that's what we're writing here, and we can use that to solve for x. I just multiply both sides by 13. Those 13s cancel. You can see I multiplied 0.8746 by 13. I can multiply this whole decimal by 13, actually, if I want to be more accurate. Either way, it'll be fine. I'm going to round this. 11.37 looks good. And so that missing side is close to, not exactly, 11.37. So let me do another one. I have this side that's 60. I could use a special right triangle here, but I want to use trig today. I have my hypotenuse is 11. X is next to that angle. We'll call that A for adjacent. The side is opposite from my angle. We'll call it O. So again, I'm looking to figure out the adjacent side. I know the hypotenuse. Cosine is the relationship between adjacent and hypotenuse. So I'm going to choose cosine here. Right here, we plug in the angle measure, 60, equals my adjacent side, x, over my hypotenuse, 11. I can go into my calculator and do cos 60. Functions, cos 60, and I get 0.5. That's nice and neat. And then I can solve this for x. I multiply by 11. And I get 5.5. Don't need to round anything there. 5.5, that's good. So I'm labeling my triangle OA and H according to the angle measure that I know. And then I'm picking the trig function, the trig ratio that involves the side that I'm looking for and the side that I know. So I'll set this one up. I won't finish it, and then I'll have you try one. Here, 56, this is my hypotenuse. This side is next to 56, that's my adjacent, and x is my opposite. So here I have the opposite side I'm looking for, and the hypotenuse is what I know. Opposite and hypotenuse, those are involved in the sine ratio, the sine function. So I'm going to say sine of my angle is equal to my opposite side over my hypotenuse. So what I want you to do actually is just finish solving this one. Pause it and finish solving this one. So use your calculator to figure out sine 56 and solve for x. And let me fix this mistake. I wrote h for hypotenuse when I wanted to write 18 because that's how long the hypotenuse is. So pause here, finish solving this one, and then press play for the answer. So when you do the sine of 56 in your calculator, you get a long decimal. We can round it to 0.829. The more decimals you have, the more accurate your final answer is. I multiply both sides by 18. So when I multiply that decimal by 18, I get approximately 14.9. So our opposite side is approximately 14.9. And if we really wanted to, we could find the other side. We can use Pythagorean theorem to find the other side, or we can use A over H cosine. But there are multiple ways then to find the third side if we wanted to. But for now, this is the one we wanted to find. So there are some questions related to these four problems. Please make sure that you watch all the way to the end and you answer the questions that pop up. As ever, if you have questions, please feel free to raise your hand and ask for help. And practice is what's going to make this better for you. Good luck.